Hello everyone. So in the last video we learned how to solve system of differential equation which are homogeneous in nature. So in this video we will try to solve system of differential equation which are non-homogeneous. So as usual in the case of differential equation we used two methods, a method of undetermined coefficients and variation of parameters. Here also we will have two such methods. So we'll try to cover both of them in the same video. So first example concerns undetermined coefficients. So let us take the following differential equation: x prime equal to ax plus t 2 minus 4, where A is the matrix 1 2 3 2. So okay, so one can check that it has eigenvalues -1 and 4, and the corresponding eigenvectors are -1 1 and 2 3. So we are not going into detail of that. Okay, so the solution for the homogeneous part xct is c1 e power minus t minus 1 1 plus c2 e to the power 40 2 3. So this is the thing. Okay, so one can see that the non-homogeneous part consists of only polynomials, so it does not involve any e power something, e power minus t or 40. So we'll use usual guess we'll put. So xpt, we guess that it's t ab plus cd. This is a guess, right, for polynomial of order. If you have t square, you have one more t square into suppose ef. Okay, so now it will satisfy this thing, the differential equation. So from here x prime t to the 1 dab, other thing will go to 0. So now if I use this thing is equal to a of xp t plus t2 minus 4. This is fine. Okay, so let me write it down. So here it's ab. Now a of xp is a of ab. So t times a of ab is a plus 2b and 3a plus 2b. This thing plus c plus 2d 3c plus 2d plus t times of 2 minus 4. Fine. Okay, so now we'll equate the constant terms and the term containing t. Okay, so this plus this will be equal to 0, this plus this will be equal to 0. So a plus 2b equal to 2, sorry, minus 2, and 3a plus 2b equal to 4. This thing I have, and a equal to c plus 2d, b equal to 3c plus 2d. So once we solve this system involving a and b, we put the values of a and b into this system and then solve c and b. Okay. So once you solve it, you will get a equal to 3, b equal to minus 5 by 2, c equal to minus 11 by 4, and d equal to 23 by 8. Okay. So once we have this, we have the particular solution. So hence xpt equal to tab, it was to 3 minus 5 by 2 plus minus 11 by 4, 23 by 8. So now once you have the particular solution, the general solution is so suppose this is 2 and this is 1. So general solution xt equal to, we know it's xct plus xpt. So I'm not writing because the expression is big. So this is from 1 and 2. Okay. So this was the method of undetermined coefficients. So in place of this non-homogeneous part t into minus 4, we can also have sine, cos, those things. All those cases what we did in the usual undetermined coefficients. Okay. So now the next technique is the variation of parameters. So maybe I will write it down here. So undetermined coefficients. This is undetermined coefficients. So the next example will use variation of parameters. So we'll use variation of parameters. So suppose you have x prime t equal to a x prime t plus some gt. So this is the non-homogeneous part. Fine. Now you create a fundamental solution set. So this is matrix will give you the eigenvectors and eigenvalue, those things. So from there you create x c. Okay. Then how to find the particular solution? This is given by xct times integration of xct inverse gt dt. Okay, so this is matrix multiplication, so this is fine, but integration is pointwise, means entry wise integration. So this is the main thing. Okay, so let us see through an example how to do it. Suppose a here is minus 5 4 1 minus 2 and gt is e power 2t 6 minus 1. Okay, so you can check the eigenvalues of this thing are minus 1 and minus 6. Minus 1 with eigenvector 1 comma 4, this is one eigenpair, and minus 6 with minus 1 1. Okay. So these are the two things. So from here we create xct. So this is a matrix, this is not Zilabit. So this is how we get e power t 4 e power minus t e power 60 minus e power 60. So it is nothing but we just multiply. We just multiply e power, the solution is what? E power minus t, e power minus t into 1, this thing, e power minus into 4, this thing, e power minus 6 into minus 1, this thing, e power minus 6 into 1, this thing. So this is how we create the matrix xct. Okay. So x inverse, so gt we already have. So then x, this inverse you can always calculate, this times gt. This will check if it is e power 3t minus 5 e power 8. So next integration xct inverse gt dt is nothing but integration of each term. This thing integration of minus 5 e power 8t dt. This is also easy to calculate. This is 1 by 3 e power 3t minus 5 by 8 e power 8t. Up to this is fine. So by definition, so from star, if we take this as star, then from star. What is xpt? Is nothing but xct times integration of this thing we have already calculated just now. So this is this thing. So xct into, interesting. So I'll directly write what will multiplication it will come out. It will come at as e power 2t 23 by 24 17 by 20. This will come out. Okay, so this was expected, right? Because uh, we have only e power minus t and e power 60 as the homogeneous solution, but here it is e power 2t, so it will be something e power 2t times constant, and constant to find a constant. We could have also done this by undetermined coefficients, but we use this example just to learn the technique. So if you have some functions here which you can't guess a particular solution using undetermined coefficients, then you have to apply this method only, variational parameters. So hence the general solution is xt equal to c1 e power minus t 1 4 plus c2 e power minus 60 minus 1 1 plus this quantity e power 2t 23 by 24 17 by 24. So let's quickly recall. So if you have gt here, if you want to use the variational parameters method, we have to find the particular solution by this term xct. I explained how to generate this xct from the homogeneous solution. You do xct inverse gt and then integrate and multiply with xct, and this gives you the particular solution. Okay.